been my own man. Always stood on my own too. I was used to not having shit. Now I do whatever I want to do.
Hi, my name is Anil Nair, and I'm an aerospace engineering student here at UCLA. And I'm going to help you by going over some math concepts and examples. Good luck.
In this video, we're going to do higher order derivatives and trigonometric derivatives. So we're going to start with higher order derivatives. So far, we've had a function, and we find its derivative by using the operator d dx. So that's just doing that. This is called the first derivative. So we can apply d dx again. And we get something called the second derivative. And there's two ways to do the notation for this. One is this, d squared f dx squared. And this is just showing you that we're using the d twice. Once here, and the dx twice. Once here, and the f once. Another way we can write this is just f double prime. And then we can keep going, add one more d dx. And this will be the third derivative. And we use similar notation. And f triple prime. And we can keep doing this, and the only thing that changes from this point on is the second notation. This is just d4 f of x dx 4. But this, we just write a 4 in parentheses up here now. Some people use Roman numerals. So we can just do a quick example. If you have f of x equals x to the third, the first derivative, as we know, is 3x squared. Our second derivative, which is the derivative of that, which is 6x. And the next derivative, the third derivative, would be 6. And then our fourth derivative would be 0, so you have a constant. And then from that point onward, since we have 0, which is a constant, we're just going to get 0 for the 6th, 7th, 8th, 9th, and so on and so forth. And the other really important thing about higher order derivatives is their physical meaning. If we have position function of an object moving, the first derivative, p prime, is the equals the velocity. So the speed and direction, and then the second derivative of that, which is the first derivative of velocity, is the acceleration. So if you're ever finding velocity or acceleration from position, you just take one derivative or two derivatives. So now we have the trig derivatives. And this really all you gotta do is memorize. So we have the derivative of the sine function, which is just cosine. And then we have the derivative of the tangent function, which is secant squared. And then we have the derivative of the secant function, which is secant x tangent times tangent x. And then we have the co-versions of all these, cosine, cotangent, cosecant. And really all you have to do is memorize the first half of this list. Let's see why. So cosine is just, for all of these, the cos, we're going to have a negative in front, and then we're going to take the derivative we already have and either put a co in front of it if there isn't a co, or take a co away if there already is one. So cosine will just become sine x. Here we go. Cosine to sine. Secant squared x will become cosecant squared x. And there's a negative, so cosine is negative sine. Secant squared becomes negative cosecant squared. And then secant x tan x becomes negative cosecant x cotangent x. So really, if you can remember the first half of this list, you'll be able to figure out the second. Just by putting a negative and changing from co to no co, or the other way around. And that's pretty much it. You'll have to do chain rule, so there might be cosec. You might have like cosecant of x squared. You might have to do multiple derivatives. All the stuff we've done before.
Then we woke up and we did that. And now we rich and now we